You know, in our digital world, we tap, we swipe, and we move our money around with a kind of blind faith. We just expect these incredibly complex systems to work, right? But what happens when they don't? What happens when a system that millions of people rely on just stops? Today, we're going to tear down a major digital crisis and see exactly what happens when the dominoes start to fall. Let's get right into it.
5 hours and 45 minutes. Just think about that. For pretty much an entire workday, millions of Barclays customers were completely locked out of their own financial lives. This wasn't just some tiny glitch. This was a full-on digital blackout. No checking your balance, no making that urgent payment, no managing your money. That single number, it represents a massive, massive disruption. So for this explainer, we're going to treat this whole thing like a detective story. First up, we'll look at the setup, the complex system that actually failed. Then we'll follow the ticking clock of the 5-hour failure, minute by minute. After that, we'll join the investigation to unpack the real root cause, see the widespread ripple effects of the aftermath, and finally, we'll lay out the blueprint for building a much stronger system. To really get how something breaks, you gotta first understand how it's supposed to work. And this wasn't just an app on your phone having a bad day. No, this was a failure deep, deep inside the bank's core digital infrastructure. Okay, so let's get the basic facts down. On October 28, 2024, the Barclays mobile banking app just went down. The specific problem, an authentication service failure. In plain English, the part of the system that confirms you are who you say you are was broken. This was immediately called a Severity 1 incident. Now that is the highest possible alert level. Think of it as the digital version of a 5-alarm fire. It means everything stops, and it's an immediate all-hands-on-deck emergency for the engineering teams.
And this is so important to understand. This wasn't just one piece of software that failed. A modern banking app is really a complex digital nervous system. You've got the app on your phone, you've got the servers with their operating systems, and a ton of security components. Then there are the APIs, the messengers that let all these different parts talk to each other. It all sits on cloud infrastructure, and the whole thing is watched over by monitoring systems. A failure in any one of these layers, well, it can bring the whole system crashing down.
All right, now we get to the timeline. This is where you see how, as the minutes ticked by, a totally routine update spiraled into a full-blown crisis. You can just feel the pressure mounting on those engineering teams with every single failed login attempt.
So check out how this all went down. At 6:45 in the morning, a standard automated security patch starts to roll out. Totally normal stuff. But then, 2 hours later, at 8:45, the monitoring systems just light up like a Christmas tree. Login failures are spiking. Just 15 minutes later, it's officially a major incident. Now, the engineers are fast. By 9:45, they've already figured out the new patch is the culprit. So the obvious fix is to just roll it back, right? But then, at 10 a.m., the one thing that was not supposed to fail did.
This right here, this is the moment where a really bad situation turns into an absolute catastrophe. The automated safety net, that one-click fix to undo the whole mess, it fails. It fails because of some unforeseen incompatibility. This is what forced the teams into a slow, painful manual rollback that took over 4 more hours to finish, all while millions of customers were just stuck. This one failure is what turned a minutes-long outage into an hours-long crisis. Okay, service is finally back online. The fire is out. Now the investigation begins. And the goal here is not about finding someone to blame, it's about understanding the systemic weaknesses that let this happen in the first place. In the industry, this is called a blameless postmortem, and it's absolutely crucial. Now, it's really tempting to look for that one single mistake, right? That one line of code or that one person who pushed the wrong button. But in systems this complex, the reality is almost always way more layered, and honestly, a lot more interesting. It is almost never just one thing. The very first domino was a logic error buried in the new security code. So, to put it simply, the update was trying to be extra careful about suspicious logins. But the code had a flaw. It started flagging people who were using older, but still totally valid versions of the mobile app as a security threat, and it just flat out rejected them. That's why some people could still get in, while millions of others were completely locked out. And this slide just shows that chain reaction perfectly. You can see how one failure led right to the next. The first domino was the testing limitation. This bug should have been caught, but their test environment only used the newest version of the app. That led to the second failure, the rollback weakness. The recovery system just wasn't built to be backward compatible. And that revealed the third failure, which is more of a cultural one, an over-reliance on automation. Yeah, the system was great at pushing out new code, but it seems like nobody had really stress-tested how good it was at pulling that code back in an emergency. Each failure just made the next one worse. A technical problem of this size is never just a technical problem. The failure rippled outwards, creating these massive consequences for customers, for the bank's own day-to-day operations, and of course for its public reputation.
Yeah, the impact wasn't just technical. It created this huge ripple effect across 4 key areas of the business, as you can see here. It slammed the customers, it created total operational chaos, it did some serious damage to their reputation, and you better believe it had a real financial cost. Let's break each of those down.
For customers, this was a day filled with frustration and, frankly, a lot of anxiety. I mean, imagine you're trying to pay an urgent bill or send money to a family member, or even just check if your paycheck landed, and all you get is an error message over and over again. For almost 6 hours, millions of people were literally cut off from their own money. That is a deeply unsettling feeling.
And internally, it was controlled chaos. Call centers and bank branches were just flooded with calls and visits from panicked customers. The elite site reliability engineering teams, the SREs, had to drop everything they were working on to fight this one fire. And that fighting mode has real costs, not just in overtime pay, but in all the lost progress on every other important project that got abandoned that day. And in our world, outages do not stay secret for long. The hashtag Barclays down was trending on social media within an hour. News outlets picked up the story, blasting out the customer frustration to an even wider audience. This kind of public failure erodes trust, and damage to a company's reputation for being reliable, that can last so much longer than the outage itself. But here's the most important part of any failure: what you learn from it. The investigation didn't just point fingers, it created a clear blueprint for how to build a more resilient system and how to stop a crisis like this from ever happening again. Looking at this, you can see how each piece of that digital nervous system we talked about offered up a really clear lesson. The security update showed that your tests have to reflect the real world, not some perfect, ideal version of it. The application failure proved that supporting older versions of your app isn't optional, it's critical. The database problems show that any change you make has to be easily reversible. And hey, on a positive note, the monitoring systems did their job. They spotted the problem fast, which probably saved hours of additional downtime.
So how do you turn those lessons into action? Well, it boils down to 4 key changes. First, you have to improve your testing environment so it's a true mirror of what's happening live, including all those older app versions. Second, you got to strengthen your rollback process so any deployment can be undone in minutes, not hours. Third, you introduce canary releases. That's where you roll out an update to a tiny group of users first, like 1%. If anything goes wrong, the damage is contained. And finally, you build better ways to communicate with customers when things do go wrong.
You know, this whole incident is just such a powerful reminder of the invisible, incredibly complex web of technology we all depend on every single day. It really makes you stop and think, doesn't it? The apps you use for everything, banking, talking to friends, getting work done, are they built on a foundation that could withstand a similar chain reaction of failures? It's a question worth asking.